Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh. Today we will continue our lesson in 2D kinematics with the more interesting topic, which is the kinematics of slotted links. Okay, so we go to the next mechanism, slotted link. So some mechanism consists of slotted or sliding part to achieve a required motion. In this case, we can assume the sliding point or the sliding pin as a particle, and we can use some of the particle kinematic formula to release the position, velocity, and acceleration of that point to other point on the mechanism. So, if we have a slotted link, normally the thing that slot moving in the slot is a pin. So that pin we can consider it a particle. So that's why you can see the slotted link question sometimes exists in the question 1 and sometimes exists in question 3. Okay, because it almost similar. So based on the situation, we can use either rectangular component xy, radial and transverse component r theta, or polar coordinate, and normal and tangential component. Okay, and sometimes we need to combine. Okay, so that's why I say that you need to understand the kinematic of particle to solve this problem. Okay, so this is one of the question. So the piston D pulling a slider B, and this slider B, once it pulled by the hydraulic ram, it will slide along the bar AO, and due to that, bar AO also rotates about point O. So you need to analyze that motion. So if we refer the collar B to the hydraulic ram D, which is a fixed point, then the velocity of B given by V1 in J component. Vertical, this is vertical. So this is V1. So this V1 will give the absolute velocity of VB in J component, and as well as if it has acceleration of also AB equal to A1J. But if we refer to point O, this collar will slide to point O with the radial velocity, or sometimes we call it a relative velocity, because it is relative to point O. And due to the rotation of bar AO, it will create the tangential velocity V theta, which is perpendicular to the VR. So if we refer to point O, we will get VB given by VR plus V theta in vector algebra, and of course AB also given by AR and A theta. So normally this question need us to find the omega of the bar OA. So for omega we need to use V theta. Okay, so VR and AR, which is the relative velocity and acceleration due to the sliding of collar B or rod, and V theta and A theta is due to the rotation of rod AO, see about point O. Okay, so V theta will give us omega by using V theta equal to omega cross R, and A theta will give us the alpha, which is A theta equal to alpha cross R. So then we can relate this V theta and A theta by VB equal to V1J and AB equal to A1J. So in that case, you need to know the trigonometry. So you need to be expert in the trigonometry so that you can resolve the components into the most easiest way. So in this case, that because V1 equal to VR plus V theta, meaning we can break it, V1 into V theta and VR by using the given angle. So in this case, the angle theta given. So by using this angle, so V1 equal to VR equal to V1 cos theta. So V1 cos theta equal to V theta. V1 cos theta equal to V theta, and then V1 sin theta equal to VR. Okay, and so as the acceleration, A1 cos theta equal to A theta, A1 sin theta equal to AR. So the second mechanism, we can see that this is a L-shaped bar rotating about point A, and the pin C attached to that bar. So therefore, if we refer to point A, this A, B, D bar will produce the velocity of point C, VC, given by omega C cross RC. So RC from point A to point C, this is RC. And of course, AC given by alpha cross RC minus omega square times RC. So this is the VC perpendicular to the radius. Okay, so we know the direction, but we didn't know the magnitude. Since this linkage given, omega is given on this linkage, then we can link pin C to point B, point E. So again, due to the rotation of link EF, then it will produce the tangential velocity V theta perpendicular to the radius. So the radius, so this is the radius for V theta, and due to the sliding along this vertical slot, it will produce a relative velocity VR. So you can see that this is not a radial velocity anymore. This is a relative velocity in vertical direction. So that's why I say that you need to adjust the component based on the situation. Okay. So, but this is still relative. Why? Because it is relative to the V theta. Because V theta is consistent, and pin C will move with the relative velocity in the slot. So VC given by VR plus V theta, and again this is the vector algebra, and also AC given by AR plus A theta, and as usual, we only focus into the V theta because we need to find the omega, and also the A theta because we need to find the alpha. So in this case, the total velocity of VC, which is due to the rotation of rod ABC about point A, can be separated into V theta and VR using this equation. So VC cos theta equal to VR, and VC cos beta equal to V theta. So beta, this angle. So you need to find the angle, and theta is the angle between VC and VR. So if we go to the real question, then it will be easier. So in this case, I just need to show you how we can relate the velocity of the body and the velocity of the particle in the slotted mechanism. Okay, so this is another problem, but this one is quite simple. Okay, so if we refer to point C, so this is point C, even though there is no radius, this is the circular slot with the fixed radius 4 meter. So we can treat this as the normal and tangential component. So of course it will have the velocity of B, absolute velocity of B due to the rotation about point C, which is perpendicular to the radius, and of course acceleration also tangent to the radius VB and AB, and along the radius AN, A normal. So, but if we refer the pin B into point A, so in this case we can see that A is moving. So A is not a fixed point. So VB given by VA plus VB stroke A. VA plus VB stroke A, and AB also given by AA plus AB stroke A. And by computing the value of VB, by using this equation, we might get VB in some IJ component, and then we just need to equate or relate with this VB in the same component IJ, and then we can find the whatever thing is required. So normally, of course, it need the omega and alpha. Okay, so with that, I thank you all for be able to follow me this afternoon.